Thank you. Thank you, guys. So today we will continue the incident response in Google Cloud Platform series. My name is Daniel Rodriguez. I'm from Colombia. I work as a security consultant. My passion is incident response and digital forensics. And it started because I read the book, The Google Sec, a few years ago, and I start to get involved. So I was working in hacking, and I read that book, and I say, oh, this looks interesting, and I start to understand forensics, and now I love lead investigations. My Twitter is @devirus, and my website is devirus.training. So let's start today. We will investigate virtual machines attacks in Google Cloud. So it's one of the easier scenarios. And next week we will talk about crypto mining, Kubernetes, and like every season we will check more advanced topics. And today we will talk about VM logs or virtual machine logs, network traffic, snapshots for forensic purposes, questions, and at the end, pizza and beer. Okay. If you have questions, just raise your hand and we can answer. So this is the architecture that I built today for our demo. So we have a website in Google Cloud. We have a Cloud DNS. We have a Cloud Content Delivery Network that basically takes all the media, videos, images, is stored here in the cloud storage. We have a load balancing, 2 web servers with Nginx, and 2 SQL databases. So what are the most common virtual machine attacks? The first one is defacement. That is the case that we will study today. The other one is ransomware, very famous. Crypto mining is, I think this is the biggest threat now in cloud access and include environments, because people can take this to mine crypto. Denial of service, and the last one is data theft. So as I said, today we will investigate a defacement in GCP. What is a defacement is when a threat actor or an attacker change the look and feel of the website. Sometimes just to tell the world that the security in this company sucks, or sometimes it's for political reasons or other reasons. So yes, one of the alerts says that this guy took advantage of the security of this web server, and our mission is to start an investigation. Something important is in Google Cloud, we have this VPC that is a virtual private cloud, and all the things that we will do today is according to this VPC. All of those are in 2 zones, the zone A and zone B, and this is super important because if we deploy virtual machine for investigation, we need to deploy the virtual machine in the same region. If not, we need to pay for the traffic or just for extra traffic, like all the unbound traffic. And if we want to download virtual disks to start a forensic investigation that can have like terabytes of data, we will pay for that. So if it's in the same region or zone, we will not have to pay for the data transfer. So when something like this happen, some companies, some mature companies, they have, oh, okay, we have a playbook for this. If you never have working in a playbook, there's 2 good resources. It's completely free. The first one is incidentresponse.com/playbooks. So I will open this to show you. So there's free playbooks. You can use it. This is quite old. It's like 8 years ago, and we can see different scenarios like malware outbreak, phishing attacks, data theft, and others. So we can just click, for example, in this unauthorized access, and we can see all the phases of the incident response process. So prepare what we need to prepare for an incident like this. So there's a diagram here, and we can export this and use in our security operations centers. I started to use this years ago, but yeah, I don't like this anymore. And yesterday there was an update to these open source playbooks that is created for a French association, and they have different languages: English, Spanish, French, and Russian. So we can go here. Look, it was updated yesterday. Because the last update was on like 5 years ago. It was pretty basic, but now they put more scenarios and more details in the playbooks. So we can go here, and there's a specific playbook for website defacement. So if we don't know what to do if we are victims of a defacement, here we can find some guidelines. So what tools do we need to deploy, the 6 steps from incident response, what we need to prepare, like general things, how can we identify an attack of this. So usually it's because the web page is modified, but who are the first that notice this is the customers or the users of the web page. Sometimes we can detect with tools, but it's quite difficult. In general, it's people, and they put this in internet and social networks, so this kind of incidents spread quickly. Good. Last month I explained about Mitre ATT&CK. I explained the attack trees. I explained an old attack that was in 1995. That was the first playbook created or attack tree. And today I will show you something that I use in all my engagements when I do incident response. And I use this in 2 stages. The first in preparation, and the second when I build my report, because it's one of the best tools to explain to somebody that is non-technical what's going on in the incident, what happened in the network. So I start to use this to tell stories about these attacks. So before to show you this, we'll just close. So before to start the creation of the attack flow, I build this defacement TTPs. So we put what is the most probable initial access. So I start to think like the adversary. Okay, how can the threat actor exploit a vulnerability in our website, or how can he achieve the attack? So I put some scores here. So how I do this, I just put a score here. So I select the technique and I put a score. Can be 0 to 100 or 0 to 5, or is on you. So this is 5 because for me it's the most probable. And for this I put a 3, and for this I put a 2. And how can I get the colors? I just change the color setup, and I can set, okay, the lowest value it will be 0, and the highest value is 5. So if I select another one, like for example this, I can set the color, the score, or I can put just a 1, and the color it will change. So with this, I can tell to the customer, okay, this is the incident that we will investigate. So this is the most probable path. So I will start to follow the techniques with the highest score. Why? Because when we start an incident response investigation, we need to create an hypothesis. So this is my way to create an hypothesis. Something important here is you can use different patterns. So red to green if you want, but for me green is good. So I usually use green to red. And yeah, the most dangerous techniques I put a high score. So once I finish this, I go to attack flow. So attack flow is a tool created by Mitre and Center for Threat Defense. Is published in GitHub, and it's a nice tool to document incidents or to explain the different paths that an attacker can use. So I just need to create, and there's an option here. So attack flow, and I can select actions, assets, conditions, and operators. I can use attack patterns, campaigns, course of actions. So there's a lot of options. We will see this in action in a few seconds. Uh, Observables. So if I want to export indicators of compromise, I can document here and export this in a JSON file and put this in tools like MISP or other open source or IOX tools. So I will start with a simple action. So I will select action and I will take this for action. So I will select this, checking view technique. And the technique here is exploit public-facing application. Why? Because the case is a defacement. It's a web application that is exposed to internet. So one of the root causes can be that it was a vulnerability in the website, or the web application wasn't patched, or there was a bad code. So it was a SQL injection or cross-site scripting or any other kind of vulnerability. So I will put this here in the action, and I can start to document. So I use this to teach to my students what is the technique, what is the tactic that the attacker is using, and which type of evidence we can use in every stage. Because here we can see, for example, when I select this technique, I can see some information, but imagine do this in every scenario, possible scenario. So it will take a lot of time. So now I built some playbooks like we saw previously, and I have everything documented for the different public cloud environments. So if we are dealing with a DDoS, I will just open this and I will explain, okay, we need this type of evidence. So let's see if we have the evidence, or just for during the preparation stage. So if there's a new project, I can tell my customer, okay, this can happen. It's a risk scenario, and we need to enable specific logs or specific forensic artifacts, because in case that an incident, we will be prepared. So this is a way to do this. And here I can select the tactic ID. So I will just copy the tactic ID. In this case, the technique is this, and the tactic is part of initial access, because it's how the attacker get access to our environment. So I will copy this ID and I will just paste here, and I can put a reference, so I can paste this. Why? Because if my colleagues in the SOC needs to understand the attack, they just can go here, copy the links, and understand, okay, what kind of attack is this? How can I mitigate this attack? Or what information can I use to start an investigation? I can select the technique ID, the technique reference, and explain the attack. So sometimes I just copy and paste this. Sorry. Description. And here there's the confidence. So I can select, no, this will never happen, or yes, it's high probable, or is very probable that in a scenario like this, like certain. So I can use put all these techniques and see what is the most probable attack. So I built this one that I will share with you. It will be in my GitHub repository. All of these will be open source, so I'm creating this and I will share with the community. And what I'm doing here, so I will. So we start with the threat actor and our GCP virtual machine instance. So the threat actor will take advantage of this virtual machine using this technique that is exploit public facing application. So here there's all the documentation, and if this happens, I put which evidence we will need to review in GCP to see what's going on in our environment, how the attacker entered to the, or just to prove the hypothesis that I'm creating. So here there's two sources of evidence. The first is application logs. So here's a brief explanation, and if I need more details about how can I enable this artifact in GCP, they can just click in the link and go there. And the other is VPC flow logs. If we don't have this, we can go through Cloud Ops agent. That is another type of evidence that we can use. So when the incident starts, I will say to my customer, okay, we need this, this, and this. Do we have this evidence? No, we cannot help you. Because sometimes we start the incident, we request access, and at the end, we discover that there's no evidence, like we saw in the previous talk. And the same with all the stages. So if I want to see if the attacker was able to execute commands, I need sysmon logs. And this is something cool. Sysmon was created for Microsoft environments, but the last year was released for Linux. And it's pretty cool because I can see if a library was loaded, or if a command was executed, or a file was called. That is something that we never see in the logs, in the regular logs. So, and there's some Java rules or Sigma rules that we can just read the logs, and this can give us an alert if something evil is happening in our network. So all the incident that we will talk today is documented here, and we can see every evidence that we need, or each evidence that we need. Any questions? Okay, I want to share another tool that is not in the presentation. So when there's incidents, usually we use like ticketing systems or Excel or a Word file. But this is an amazing tool called Aurora Incident Response. It's for free and it's pretty cool. It works in Linux and Windows. And I can create all my investigation here, and at the end it will create a report. So yeah, it's just an Excel file, and at the end I can show to my customer, okay, this is how the attack looks, or I can show a timeline of the attack and explain in different ways. So we don't need to use Excel anymore. Years ago there was a famous spreadsheet that we used to put everything in Excel and set some information there, but now we can use this free tool. Another thing that I forgot about this tool is these guys have here in the tool, you can go to the GitHub repository and you will find this folder called Corpus. And in Corpus, we have different threat actors attack flows. So if we need to understand how Conti ransomware works, we can just download this file. So I will do that in this moment. And here is all the attack. So we can understand all the properties of the threat actor and each step of the incident or the threat actor. Great, so it's time to start the investigation. So as we see in the flow attack, we need some evidence. So what we need access logs that is from the Nginx server. Without these logs, we cannot see if or show to our customer that when this incident happened, and because it's a key evidence. One of the problems of these logs is that if the attacker got access to the virtual machine, he can destroy the evidence. He can just override the logs or just delete the logs. But I will show you an alternative that we can use in GCP. The other source of evidence is the firewall logs. Are disabled by default, as I explained in the last class. VPC flow logs are disabled by default, but nobody tell us these things. So when we set up a security operations center, we think that we just need to turn on the virtual machines and put an agent, and we will receive all the logs in the security tools. But that's not true. We need to set up or change some things in GCP, and it's the same in all the public cloud providers. We can capture network packets. It's disabled by default, of course, because are a huge amount of data. And the last source of evidence is create a forensic image, to investigate the whole system. Something to understand is that every option that we enable in this environment, we will cost. So we will pay for the API consumption, we will pay for data transfer if we move data to another regions or we download data to our computers, we need to pay for that traffic. And there's a lot of logs and virtual machines or these images that we need to download. Storage, because if we took a snapshot or we make a copy of a virtual machine, we need to pay for the storage, the bucket or the storage that we are using. And the resources. One of my recommendation is to create a virtual machine inside GCP and start all the investigation in this virtual machine, because in this way we will not pay for the traffic. But we need to pay for the CPU, the RAM, and the disk. Okay, let's start with the investigation of the logs. First, I will explain how the logs work in Google. We have this logs data that can be generated by the firewall, by a virtual machine, by a database, or any other resource. And there's a cloud logging API. So this API takes all of this data, and this is we call log ingestion. So he took all the data and he passed to a cloud router that in GCP it calls a stack driver. This stack driver makes the log aggregation. What is this? That he took specific rules, so he can detect if it's a firewall log or if it's operating system log, and he can filter this and pass to different sinks. The sinks are buckets. Sorry, the sinks is just preprocessors. And these preprocessors took the data and send the data to a specific storage, or I can send the data to a BigQuery function to create alerts, or I can just create a cloud function and send to a CM tool like Splunk, Elasticsearch, or any other tool. Each bucket have retention. So the required logs are 400 days retention. So that's really good that we have a lot of data here. The default buckets that usually is used for custom applications. So it's not When the log is not generated by GCP, we can use this custom bucket or default bucket. One example is if we are creating a log for our mobile application or for a specific API, we can send these logs to this bucket. And the other is another called use define buckets that it has a 30 days retention. There's a good thing in GCP called Cloud Ops Agent. So this agent will solve the problem that we have about storing the logs in the same virtual machine. So it took the log in real time using syslog or using the function from Windows, evtx logs, using a fluent beat, and this agent will take the logs that we set, and it will send to this new bucket. So I will show you how it works. Okay, this option is disabled by default. So we need to download. So we open our virtual machine and we can just execute this command. We need to install this agent. So it's a bash file. And in Windows, it's just an executable file, as MSI file. We need to edit this configuration file. So I will show you why it's important. And the last thing is restart the service. For the agent needs to take the configuration and add more information to the agent. By default, the agent, when we install the agent, it will just take the message log from a Linux machine, or on in Windows, just the security, application, and system logs. But if we need custom logs, like in this case, Nginx logs, we need to tell to the agent, okay, took these logs, pass to syslog, and send this to GCP API. Okay, so this is the configuration file. It's a YAML file called config, and by default is empty. Just have these comments, like these lines from here to here, and I added these rules. So the first is the logging, which logs the syslog will receive. So in this case, I'm telling, okay, took the bar log messages, bar log syslog, and I will add bar log nginx access log. In this case, I will be able to see who entered or who is attacking my web application. More rules. So the receiver is the syslog service in Linux, and I'm adding some metrics and the collection interval. So it will collect logs every 60 seconds. The function will send the logs to the API. And after that, I just need to save the file and restart the service. Okay, so once we finish the installation of the cloud agent, we can go to this option in GCP called monitoring. And here we can see virtual machine instances, and say that one virtual machine has a ops agent installed. And why is so important? Because now we can get the logs in real time from this virtual machine. So if the attacker deletes the log, we have these logs in this module, so we'll not lose evidence. And here I can just select my virtual machine. And another cool thing is we can get these graphics, like what is the CPU use, the memory use, and the network traffic. Why this is so important? Because if it's a crypto miner, we can see like high consumption of the resources. If the attacker took data and sent the data to internet, or he downloads the files, we can see different metrics in the network graph. Like here, like we can see, okay, there's a traffic peak in this time, so we can go and see the logs in this specific timeline and see what happens or what is happening. We have metrics and we have logs. So in the logs, we can see in real time different logs. Use this view, and I will run this query, and I can see the logs. So I can just select here. We can see that is the web server. So he took the virtual name instance, and we can filter according to the tag that we set at the beginning of the creation of the virtual machine. And we can see all the data. So the attacker puts this web shell. It was the attackers use this as a persistent mechanism. So they use this as a backdoor, because if the server is patched, he will not able to exploit the vulnerability anymore. So when he exploited the vulnerability at the beginning, he took that advantage and he creates this backdoor to come back in any time. So this is a simple web shell in PHP. From here, the attacker is able to launch commands or execute different things, move to another machines, or do like discovery of different servers or different hosts in the network. So we'll try to find this in the logs. So we can just we just need code here, paste the name. In this case, it's very catchy because the name is not webshell.php or something evil.php. It calls include function.php. So we will never suspect that is a web shell. So here is the IP address that is calling this web shell, and we can see more information about this. We can change the timestamp to see when was the first time that this web shell was called. So it works like a CM, but we are not paying for expensive tools. And here we can see the timeline and see that the first time was, we can move there and select the timeline and see when was the first time. Good. Now is time for network logs. Network logs are disabled by default, and we need to add or enable firewall rules. So each firewall rules, we need to enable the log. So it's not an easy task. To be successful in this task, we need to understand what is the most important traffic. In this case, if it's a web application, I will select the rule that enables or allows the HTTP and HTTP traffic to my virtual machine, and just select that log. So I will show that. So here we have the firewall rules. and I just need to select the rule, edit the rule, and by default all the rules are off, so I just need to turn on the logging capabilities. And something important is this is when we enable these logs for first time, this option is enabled as well. And there's important information here. So this metadata is valuable for investigation, but it will increase the cost because we will store in more data. Sometimes we don't need that metadata. So in my investigations, I just remove this field. And we can just select here, save this thing, and we will get some logs. So we have some logs now in our VPC. So we can just go here and put this filter that takes all the firewall rules logs, run the query, and we will see what is going on in our network. Because it's not always inbound traffic, can be traffic from our virtual machines to another clouds or another networks. So we will not get that data in our application logs. That's why we need this kind of logs. Uh, it's possible with that script and run that in Cloud Shell. So you just need to list all the firewall rules and pass that as a parameter and select the option. You can select like many of those. Uh, like select, and I think there's an option here. Yeah, configure logs. Great. The next artifact is VPC flow logs. Is my favorite artifact in case of crypto mining, denial of service, or data thefts. Why? Because are logs, but are not huge. It just contain the source IP address, the source port, the destination IP address, the destination port, and the amount of data between the two hosts. So it's a great source of evidence to understand what data and which is the destination of this data. So flow logs records a sample of the network flows and send and receive by the virtual machine instances. We will activate this per virtual machine. So we need to go to the virtual machine and turn on these capabilities. It will log all the TCP and UDP traffic, and the other protocols will be not monitored, including ping. That's good because sometimes in on-premises solution or when we make configurations in firewalls or routers, ping is included. So if somebody leaves a ping, we will get a lot of noise. I will get in. I'm putting here all the configuration guidelines created by Google. So I will share this and the previous presentation, and you can just go here if you are interested. You can select. You can create a whole ecosystem in GCP just for free. So it's for 90 days, and now it's 4,000 crowns. So we have like a lot of resources, so we can play for 90 days and yeah, learn about GCP. Okay, we will turn on the flow logs. So we need to go to the VPC networks. And we will activate this for the whole subnet. So I will select this subnet that is it calls by default, and here we have the same subnet in all the different regions. Something important here, we need to know which is the region that our virtual machine is running. That's an easy task, so we can just go here to the virtual machine. Go to compute engine, virtual instances. And here it says that the zone is US West 1B, so the region is US West 1. Now I will filter this. I will select region, US West, and there's 4 different zones here. But my virtual machine is in this first one, so I will just select this. I will select flow logs, and I need to say turn on. In this case, it's turning on, but I will select another one just to show you. So I will select configure, and here we can select the aggregation interval. What is this? Is how long the virtual the flow processor will wait until add the data to the flow log. So my recommendation is 30 seconds. And something here is that when we change this, so here is the by default, but says estimated logs generated per day, 0 bytes. If we select 3, says that it will increase, and I will put 5. So say that if we use this option, it will reduce the flow log size by 98%. So it's too much. So I always use like 30% or, sorry, 30 seconds or 5 seconds. And I just need to save this configuration, and that's all. Sorry? Yeah, because it was, the other was enabled before this morning. So it was to show you the configuration process. But now I will go to this, that is US West. And we can see that is turning on, and we can just select here, and we will be able to see all the flow logs. Sorry? Yes, in this case, yes. Because these flow logs are super small, so this metadata can help to identify suspicious activities. So the metadata is like which is the virtual machine name or the label of the virtual machine, in which area is. That is information that is not by default in the flow logs. So that's why we are using the metadata in these flow logs. And now we have a lot of data about the connection, and we can see the how many bytes send the virtual machine to internet, or how many data received from the attacker machine. These logs are a great resource to see if a data breach happened, because we can like, oh, what was this amount of data at 11 p.m. from this virtual machine to, yeah, China. What's happening here? So we can start to use this and go through other artifacts to understand what happened in our network. So this is a guideline for the configuration, but you can go here, and there's a lot of tips to enable this option. This is how it looks. So with the metadata, we have a lot of detail about the data traffic. Yeah. Now we'll talk about network packets. In the traditional networks, we can turn on the packet mirroring, like in the traditional intelligent switch, that we can just tell to the switch all the traffic that is in this port, just put in this mirroring port, and we will be able to see all the data or all the network packets in our network. So we can do the same in GCP. Something important here is that we need to set up a load balancer. So it's not like I just turn on this and it will work. Why? Because Google will not accept to store these pickup files in Google storage because it's a lot of data. So if I accidentally turn on this capability, I will pay a lot of money for storage, because in 1 second I can get like 10 gigabytes of data or maybe more. So it doesn't make sense. So I will not show this in detail because it will take time. I need to create the cloud balancing and set up the packet mirroring. I'm not using this too much because now almost all the data is encrypted. So it doesn't make sense to spend a lot of time capturing traffic if all the data is encrypted. It will work if the data is not encrypted in my application. I can use this to see the payloads or understand more about the attack. And the last topic is forensic images. In all the three main public clouds is super easy. In the traditional world, for example, if I need to take a forensic image of this laptop, I need to shut down the laptop, remove the disk, put the disk in a special hardware, and start a copy bit by bit. So can take hours. And after that, I need to take a hash to see that the image is original, is a real copy of the original, and put that in my chain of custody. So here is super easy. We just took the virtual machine, create a snapshot, and that's all. I can attach this to my investigation virtual machine and mount as a read only, and I can start a forensic investigation. So it's fast. I will save time, money, and yeah, it's super easy to do these things. And another important thing with a snapshot is it works as a backup. So if I lose data, I just can restore the snapshot and everything will work again. Okay. So that was all. Any questions? Yep.
Thanks. We have discussed today a lot of settings which are not actually default settings in Google Cloud. So the question is, do you have maybe some rough estimation how much money will we pay in case if you will enable all these settings, and percentage maybe, or comparing to regular operations? Or
That's a good question, and depends of each customer, because the architecture or the setup or each customer can be different. I can just have these 4 servers and the load balancer and with few traffic, but can be the same setup with a lot of traffic, a lot of information. So usually it's between 10 or 20% of the regular billing. So yeah, we need to tell to our customers, yes, put 50% of your budget if we need to respond to an incident. But it's important. If we don't have evidence, we cannot solve anything. Right?
I have a question on the mirroring still, as you said. So nowadays data is encrypted, so we cannot have that much about the actual contents of the data exchange, but we still can analyze the traffic patterns. So if at some point based on the volume of data exchange, we can
we can see which was the IP address that started the conversation, how many data, and we can, using like tools like Wireshark, just introduce the certificate and see the unencrypted packets.
And of course, those
Yeah.
like when we do sniffing, then there's so much data, then sometimes
Correct.
it's hard to. But on the other hand, if it's regarding the volume of data stored, we can still define data retention policies, and then let's say if we keep for a couple of weeks all the data, and then with the data retention policy we just move it to cold storage or something that is cheaper, but we can
do that with the logs, but not with the network capture. As I said, the Google not allowed to put these pickup files in storage because are huge files. So how it works is we can send this raw data to tools like Moloch, that is our online Wireshark. So we can send this data and we will process this data. So we can set up like a virtual machine and he will collect all the data and he will store the network packet. But it's super expensive. I use network capture just at the moment to start the investigation. So it's not part of the preparation of the incident because we will store data that we will not use, maybe.
But then the last question is about, this is for the forensic analysis, but then for the users, when they are setting up what you mentioned, we need some like advice or guidelines, as we were showing at the beginning, the same as with Mitre, but more preventive.
Correct.
Measures. Yeah, perhaps you have it in another talk, but it's more for the application, for the developers when they are deploying the application, just to be sure that they enable, at least in the Google infrastructure.
Yeah, that's part of the threat modeling exercises. So if there's a new development in the company, we made this threat analysis and we can start to say, okay, if something like this happen and your data is critical, we need to set up these configurations. And one of the big mistakes in security in general is that we assume that all the logs are enabled, and if they are not enabled, we just tell the developers, enable the logs. But which logs? In which rule? So yeah, we need to explain why we need those logs. And one of the best ways is explain, okay, because this is the attack path and we will need this evidence in a specific cases. And it works also for troubleshooting. So if something is not working with our application, we can use this data to help in with the troubleshooting investigation. Good. Any other question? Right. So thank you very much. And it's pizza time, I think. Yes. Thank you.